Hello everyone, welcome to Get Educon. And today we will start the process management, means our chapter number 2. And here we will firstly discuss about the concepts of processes. So what is the process? So process is a program in the execution maintaining some information. Okay, and there are some differences between the program and processes. That are program is passive, but process is active. Program is a content of file stored in the disk here. So now process ID, process name, and these topics where we store, that is called as the, what is called as, this is called as the process control block. Okay, this is the process control block, and or task control block, which is TCB, process control block, TCB, or task control block, TCB, both are same. Okay, and this process control block contains the information of executing program. Clear? Like for the process one, the all information of process one stored in PCB1, for process 2 PCB2, for process 3 PCB3. Okay, so now we will discuss about the types of processes. So the types of processes, the first one is event specific based category of process. Okay, we can divide it into parts like CPU bound process and IO bound process. So what is the CPU bound process? So this processes which spends the majority of its time simply using the CPU, doing calculation types works. Okay, addition, subtractions, multiplications, and logarithm. Anything calculation based problem, or anything, we use mainly CPU bound processes. Okay, so for the computation part, we mainly use the CPU bound processes. And for IO bound processes, which are associated with the input or output based activity, like reading from files, etc. Okay, so input output transfer. So the next type is category of process based on their nature. So there are two types also: independent process and cooperative process. So the first one is independent process. So the process which does not need any other external factor to trigger is an independent process. And cooperational process or cooperative process, this is the process which works on the occurrence of any event, and the outcome affects any part of the rest of the system. This is called the cooperative process. So independent process is independent, but cooperative is dependent on some other process, or it will make some effect on the other process. Okay, so there are some process states. So the first one is new. This process is being created. Running. Introductions are being executed. Okay, waiting. The process is waiting for some event to occur. Next one is ready. The process is waiting to be assigned to a processor. And terminated. The processor which finished its execution part. This is called as the termination. Okay, so this is the process life cycle in beginner level, or the basic structure of the process life cycle. So first one is new. Then after admission of this, it will go into the ready part. After that, scheduler dispatch, then running, and after interruption it will again come back to ready part. And if it executed or scheduler dispatch done, then it will exit to terminated, not terminated part, or termination of this process. Or there will be another cycle, like after running, if IO or event wait is done, then waiting state, it will, the process will go under the waiting state. And if IO or event completion done, then it will again go to the ready state. So there are like this type of cycle. One is like this, in this way: new to ready, ready to running, okay, running to termination. This is one. The second one is, I will use the another color, like new, then running. Okay, after interruption, it will come back to ready, and after again scheduler dispatch, it will go to termination. This is another part. So this is two. Again, you can see this like new, then scheduler dispatch, then running, ready to running. After then, if wait, then it will come under the waiting part or waiting process. Then IO or event completion, then ready. Okay. After ready, it can again go to the running state. So this is part number 3, and running after that termination. So there are 3 to 4 cycles. You can see that. Okay. So I think this should be clear to you. So there are some there are mainly two types of scheduler. Like first one is long-term scheduler. Okay, so this is also known as process scheduler or job scheduler. Disk to main memory. This is the main thing. For long-term scheduler, disk to main memory. Okay, and for the short-term scheduler, it is also known as the CPU scheduler, which is main memory to CPU. Okay. Here I will draw this thing like, yeah, like disk here, disk to main memory. Disk to main memory. So this is through long-term scheduler, LTS, long-term scheduler. Okay, then main memory to CPU. This part using short-term scheduler, STS. This is long-term scheduler. This is short-term scheduler. So disk to main memory, this we will use the long-term scheduler, and for main memory to CPU, it will use the short-term scheduler. Okay. Now the next thing, this is the process state diagram in detail. Okay, so new to ready. If schedule or dispatch, it will running state. After completion, terminate state. If priority or time quantum is there, then it will come back to the ready state. If suspend, then suspend ready. And if again it will resume, then ready state. Okay, after ready, it will go for after scheduling, it will go to ready to run state. And if IO request is done for waiting, then wait or block. Okay, waiting or block. After IO completion, it will again go to the ready state. So here also for waiting and block, if it will go for suspend, then suspend or wait, and after resuming, it will go again for the waiting or block. And also here suspend wait is over and IO process completed, but still in suspend, then again it will go to the suspend ready state. Okay, I think it will be clear to me. So very frequently we have to see this diagram for being clear. Okay, so you have seen the short-term scheduler, long-term scheduler. Okay, and another is that medium-term or mid-term scheduler. Okay, which is also called as the memory scheduler. It is memory to disk to main memory to utilize the memory effectively. Means one memory to disk, then again main memory. You have seen that for memory to CPU, we use mainly short-term scheduler, and disk to main memory, we used the long-term scheduler. Means this disk to main memory, we used long-term scheduler, but this is for one memory to another memory through disk. Okay, where we use the mid-term scheduler as memory to memory, so it is also called as the memory scheduler. What is this advantage? To utilize the memory effectively, memory or medium-term scheduler is being used. Okay. Now this is the process control block, a repository about the processes. So process state, process number, process counter, register, memory limits, list of open files. This information are gathered in this process control block or PCB, or task control block or TCB. So what are those informations? So the first one is process state, which can be running or waiting. Process number means the location of instruction to next execution. Or and the next thing is CPU registers. It contains of all process centric registers. The next thing is CPU scheduling information, means priorities or scheduling queue pointers. Those informations are gathered in the CPU scheduling information. Next one is memory and management information, where memory allocated to the process. and accounting information, where CPU used, clock time elapsed. Okay, since start, time limits, these are there. And next one is IO status information, where IO device is allocated to the process, list of the open files, and degree of multi-programming also there, number of processes in the main memory. Next, the most important thing is the context switching, where switching the CPU from one process to another process. So who will do this switching work? So who will do this switching work? Switching the CPU from one process to another process. So operating system mainly do this switching work. Clear? So now what will be switched? So CPU from line context to means one context to another context. This will be switched. Okay, this is the whole scenario of the context switching. So this is the process, and it is the operating system, then process is P1. Okay, see the picture clearly. Okay, so here executing, then here interrupt or system call is there. After executing, it save state into PCB0. Okay, then reload state from PCB1. Next, in this state, after interrupt or system call, next save state from here. Okay. From here, and after that, in this way, again reload state from PCB0, then here, then executing. So this process will work continuously or in cyclic mode. Okay, so the next thing is the data structure which we use mainly during this process. So the first one is job queue. Okay, so this queue keeps all the processes in the system. Next thing is ready queue. This queue keeps a set of all the processes residing in main memory, ready and waiting to execute. A new process is also always put in the queue. And the device queue, this process which are blocked due to unavailability of an IO device constitute this queue. Okay. So this is the architecture, means job queue, then ready queue, then CPU, and from CPU it will again come back to the ready queue, and after CPU it can go under the waiting queue. After IO operation done, it will again go to the ready queue. So after this process, whole process when done, then it will go terminated or it will go into the exit state. Okay, so there are mainly three types of schedulers which I have discussed. The first one is long-term scheduler for job processors, short-term scheduler, CPU, mid-term scheduler or memory scheduler. Okay, so after that, I am going to tell you some another points like there are some which like if there will be some question like which of the following need not necessarily be saved on the context switch between processes, means during context switching, which are necessary, mainly necessary things. The first one is general purpose registers. General purpose registers. The second one is program counter. Okay, so mainly registers and counters. Program counter. These two things mainly we use during the context switching. And there will be some another option like TLB, which is what is the TLB? Means translation look aside buffers. Okay, translation look aside buffer. which we will discuss later. So translation, look aside buffer, which will be not used during context switching. So this will be the option. Okay. So the next thing I can tell you that suppose let the time taken to switch between user to kernel. Okay, user to kernel time t1. Okay, time t1 is required, and from process one, suppose one process to another process one to process two, time taken or time required is t2. What is the relation between them? Means t1 is greater than t2, first option. Second option is t1 is less than t2. Third option is t1 is equal to t2. What is the right option? Obviously t1 less than t2, as here from user mode to kernel mode transition is there, from one bit to another mode bit. What is the mode bit of user? For user mode, mode bit is 1, and for kernel mode bit is 0. Clear? So from here we mainly transit from one mode bit to another mode bit. So not much time will be required. And for process switching, means from one process to another process, like T2 time is required. So the time will be required more, as the inform means from PCB1, like process control block 1, the information which stores the information for process 1. Okay, it from PCB1 it will collect the information of P1, then through CPU, and here also it will go to process 2, and here it will store PCB2. In this way the process transition will be there, where time requires is T2. So it's obviously greater than T1. So T1 is less than T2 here. Clear? These 2 points means the previous point and this point. Clear? Now again another question I want to share, like convoy effect. What is the convoy effect? So convoy, as one process is waiting one after another, like convoy. When one process is waiting one after another, like convoy. This is called as the convoy effect. Like in FCFS means first come first serve. This scheduling we can see this convoy effect. No other process, in no other process we can see that convoy effect. We only can see this convoy effect in the first come first serve scheduling. Clear? So these are some points I wanted to share, which I have shared. So in next lecture, I will discuss about some CPU scheduling processes and CPU scheduling basic terms. Okay, so that's all for this session. Do watch, do like, share, subscribe if you like this. Thank you.